Atom Economy for AQA GCSE Chemistry. So, atom economy is a tool used by green chemistry with the aim of reducing the release of pollutants into the environment from industrial processes. It's intended to improve both sustainability and the economics of these processes. Now, a key idea in the analysis is that of the desired product versus other waste products. Let's look at an example, the fermentation of plant sugars to make alcoholic drinks such as wine. Well, the wines are the desired product. Anything else made is a waste product. But atom economy is based on a chemical equation for those processes. So glucose is turned into ethanol. The ethanol is the desired product. The waste products are identified by the equation as carbon dioxide. The goal is to increase the amount of desired products in any industrial process and decrease the waste products released into the environment. The analysis produces a number called percentage atom economy, which I've given the symbol percentage, capital A, capital E. This compares the relative formula mass of the desired products to the relative formula mass of all the reactants as represented in the reaction equation. So percentage atom economy is all based on the balanced chemical equation. And we put it into a formula that is the percentage atom economy is the sum of the relative molecular mass of all desired products divided by the sum of the relative molecular mass of all reactants and multiplied by 100 to produce the percentage. Now, a high value for the percentage atom economy means that fewer atoms are wasted and discarded into the environment. So the aim of industrial processes on this measure is a high value percentage atom economy. So let me carry out one model calculation for you, and then on the following slides there's a couple of problems. Iron is extracted from iron oxide by reduction with carbon. So the desired product is iron. Carbon monoxide is a waste product. Here is the reaction equation. I'm going to show you how to calculate the atom economy. Well, the sum of the relative molecular mass of the desired product is 2 times 56. The relative atomic mass of iron is 56, but we need to take into account all of the desired product, so we use the multiplier. 2 times 56 is 112. The sum of the relative molecular mass of all reactants, well, Fe2O3 comes to a relative molecular mass of 160. We've got 3 carbons, so 3 times 12. 160 plus 3 times 12 comes to 196. Put those into the percentage atom economy formula, which is the sum of all the desired product relative molecular mass divided by the relative molecular mass of all of the reactants. So 112, the desired product, all reactants 196. So 112 divided by 196 times 100 comes to 57%. So here is the first problem. Titanium is extracted from titanium 4 chloride by displacement by sodium. Here we have titanium 4 chloride and sodium giving us titanium and the waste product, sodium chloride. Calculate the percentage atom economy for this process. Stop the lesson, carry out the calculation, come back to check when you are ready. Okay, so to reveal, we need to work out the sum of the relative molecular mass of the desired product. Well, the desired product is titanium. The relative atomic mass of titanium is 48, so 1 times 48, 48. Now we want the sum of the relative molecular mass of all the reactants, so titanium 4 chloride is 48 plus 35.5 times 4. So the relative molecular mass of titanium 4 chloride, 48, and 4 times chlorine, 4 times 35.5. Plus the other reactants, 4 sodiums, plus 4 times 23. Comes to 282. 48 divided by 282 times 100 is 17%. On previous slides, we showed that the percentage atom economy for the production of iron is 57%. That would seem to indicate that iron production is more sustainable than titanium production, which we calculated to be 17% atom economy. But these figures do not take into account the idea of percentage yield. Let me illustrate by considering the synthesis of ammonia. 3 hydrogens and nitrogen go to make 2 ammonias. Well, the percentage atom economy for this synthesis is 100%. It must be the case because there's only one product. There are no waste products at all. So atom economy 100%. That would indicate, oh, it's very sustainable. But in industrial processes, a yield of only 15% is quite normal, which means potentially much of the original reacting material is lost. So an analysis of sustainability must take both percentage atom economy and percentage yield into account. Well done for finishing. If you want more practice, try textbook questions and then past paper questions. For more related classes, look at the playlist or links in the video description. If you found this lesson helpful, please recommend it to a friend. Subscribe for new classes and last-minute exam tips. Likes and comments are always appreciated. Thank you.